All right, so the first example we're going to look at here as with piecewise functions. And again, piecewise functions are essentially functions that have two or more different parts. This example is going to have two parts to it. So Alani has a summer job as a lifeguard. She makes $8 an hour the first 40 hours she works. If she works more than 40 hours, then she makes 1.5 times her regular hourly pay, which would be $12 an hour. But that's just for the hours over 40. It's not like once she gets to 40 hours, then her rate was just $12 an hour for all the hours. The $12 an hour is just for the hours she works beyond the 40. So the 41st hour, she would get $12. The 42nd hour, she would get $12. But like the 38th hour she worked would still just be $8 per hour. All right, so then step one, there's a table that shows, okay, well, if she worked 20 hours, she get $160. If she worked 30 hours, she get $240. If she worked 40 hours, she get exactly $8 an hour for $320. That's the part in orange. Once she starts working more hours, it goes up faster. So then that part of the graph, the slope's a little higher because she's making $12 an hour instead of $8 an hour. So that part's in green and it looks slightly different, right? And by the way, this is if you work an hourly job, this is pretty typical in real life in that you get paid time and a half for all your hours above the expected 40 that you should work during the week. So notice that the plot contains two line segments. So that's again the orange and the green. And it changes slightly once you get past x equals 40. A function that has different rules for different parts of its domain is called a piecewise-defined function. Typically, people just call them piecewise functions, but I guess technically it's piecewise-defined function. All right, so write an equation for each piece of the graph. Well, I'm going to skip down to the second half of this. That part's the easy part, right? When she works between 0 and 40 hours, the function's simple. It's just 8 times the amount of hours she worked for her pay. Eight times the hours worked, or 8 times x. When she works more, she gets 8 times 40, so that'd be $320, plus $12 times x minus 40. And the reason why it's x minus 40 is she's only getting the $12 an hour for the hours she works beyond the 40th hour. Hours 1 through 40 are included in that first part of the function, the 8 times the 40. So let's say she worked 43 hours. 43 minus 40 would be 3, and 3 is what's getting multiplied by 12 because she's only getting that $12 rate for those 3 hours, not the other 40. And again, the other 40 were already included in that 8 times 40. When you put all that together, it'd be 12x minus 160. Okay. And that's how a piecewise function is going to look. You have p of x is equal to, and you've got two things listed here. Again, a piecewise function actually could have 3, 4, 5, like whatever. It could have as many pieces as you want. This example has 2. And then there's a domain rule about when you use each function. So 0, when x is between 0 and 40, you use the 8x. When x is more than 40, you use the 12x minus 160. And obviously, this is a question with context where you don't need we don't need to be talking about anything less than 0. You can't work less than 0 hours, right? Not working is the least you can do, and that's 0. Okay. So let's look at a you try question. So at this point, pause it, give it a try, and see how you do. Okay, so essentially we're going to use the part in the summary from the last slide where depending on how many hours she has worked, That depends on which function we're going to use. All right, so if she's worked 37 hours, we're simply going to use the first part of the function, right? She worked 37 hours, which means she just gets paid $8 an hour for those 37 hours. So it's just 37 times 8. It's 296. So she's going to get $296 for working 37 hours. Okay, let's check our answer on that. We got it right. All right. For 43 hours, it's a little more complicated, right? You're using that second part of the function. So that's the part where we're going to use the function 12x minus 160. We're just going to substitute 43 in for x. 12 times 43 minus 160. So on the calculator, let's type that in. You get $356. So let's type that in. And we were good. Okay. So let's try example 2.